An introduction to data transmission. There are three varieties of data transmission, varied in the direction of transmission: simplex, half-duplex and duplex. Simplex transmission can only be sent through one direction and cannot transmit back. A good example of this kind of transmission can be seen in public announcements at grocery stores. The announcer is able to send signals through the mic, but no one other than the announcer can send any signals back. This is a one-way transmission and therefore a valid example for simplex transmission. Half-duplex can transmit both ways but only one at a time. A good example of half-duplex transmissions can be seen in walkie-talkies. Here we can see that the two speakers together can send signals to one another but not at the same time. If you're speaking, you can't hear anyone else interrupting. On the other hand, you have to pause to let others speak. Duplex transmits both ways at the same time. Duplex transmission can be seen everywhere, mostly when we talk on the phone. When we talk on the phone, we are able to send signals, which in this case is exchanging conversation on both ends at the same time. This is an efficient way of communication and lacks complications as compared to the other two. There are two ways to transmit bytes between points. In parallel transmission, multiple bits are sent simultaneously through bus lines so that bits of data can be sent in one go. Integrated circuit is an example of parallel transmission where speed is key. In serial transmission, data bits travel one after another along the same wire. USBs are an example of serial transmission shown in the name. Sometimes errors happen in transmission and they need to be fixed. Errors can occur due to outside forces changing the code. Parity checks can be used to fix this. Here's an example using even parity. A parity bit is paired with 7 other bits in a string. This bit does not have an effect on the code itself but signifies the number of one-value bits, 0 if even or 1 if odd. In this example the number of ones is even and so the parity bit is 0. If the last bit were to change value, the parity bit would not match up to the rest of the code and so the code would be reset and fixed.